Hi, we're group 14. I'm Bertram. Andreas, Calvin, and Yash are here. And we decided to do a project on encrypting and decrypting files. I was in charge of the GUI, so I used JavaFX. So I have my controller class here. It basically just connects the buttons and the text input to the correct methods. And we used FXML, of course, with JavaFX. But that's enough about me. We can go ahead and get started with the Visioneer.
Okay, hi, my name is Yash. I'll be talking about my part for coding the Visioneer cipher. The Visioneer cipher generally works by encrypting alphabetic text using a table. The table is going to be 26 rows of alphabets representing the text and 26 columns representing the key. For our part, for the process for this class, there are going to be two classes, Visioneer Cipher and Visioneer. The Visioneer one is the main one that compiles everything, and Visioneer Cipher is the actual code. If we go in there for the purpose of this class, instead of 26 characters, we're going to be using 256 characters for the bytes for reading a file. If we scroll down to the encrypt method, all the formulas are going to be in there. And we can start off by showing you the actual demo.
Yeah, so our code is over here. We have a file, book.txt. We'll have the output, book key for encrypted, Visioneer. We also have a key file, which I called key.txt. If we process it, we can see that it has been processed. And if we look in our source file location, we have book E, and here's where the D key was. So with that in mind, we can go book E, call this book D for decrypted.txt, decrypt it, use the same key, process it, it's going to be processed, and we can look at the decrypted version, which says Merry Christmas. When we try to look at the encrypted version, we just get a bunch of nonsense. Yeah, that's enough. Visioneer. Let's move on to RSA.
Hi, I'm Calvin, and I was responsible for implementing the RSA algorithm. So RSA is generally used to encrypt and decrypt session keys, but for our project, we use it as a block cipher to encrypt whole files. So one of the most important parts is generating the RSA public-private key pairs, and that's handled by the RSA keygen class. So the generate RSA key method just implements pretty much the RSA key generation algorithm that was presented in class. We find two large prime numbers, we multiply them, we apply the totient function to it, and we use that to determine the modulus, public key exponent, and the private key exponent. And the other classes in this file, scrolling down, are just classes to hold the exponents and the modulus in big integer classes. So rsa.java will implement the RSA encryption decryption algorithms. So for our project, we used a block size of 256 bytes and a RSA key length of 2049 bits. So the first two functions here are helper functions that basically translate a sequence of a block of bytes to an integer, and from an integer to a sequence of bytes. And that allows us to work with integers when we do the exponentiation. So the next function here is a crypt block function. And that will take a block of bytes, convert it to an integer, apply a key exponent to it, mod the modulus, and translate that back to a block of bytes and write it out to a output file. So this is used for our encryption and decryption. And you could determine that using the specific key you feed it, either the public or the private key. The next three functions here are just used to pad our blocks in the event that our files are not perfect multiples of our block size. So then the last two functions here are encrypt file and decrypt file, which basically read the files block by block and then feed those into the encrypt or decrypt block functions, which is pretty self-explanatory here. So then Bertram will now demonstrate the RSA encryption decryption on a sample file.
Yeah, so we can choose to decrypt, that's all right. We can choose to decrypt a image here. So we can say, go encrypted, encrypt it using RSA. And this will take a while. Our keys will be generated for us. Oh, it's been processed. That was really fast. And you can see that our keys are given right here, RSA key and RSA key.pub. When we try to look at it, it's just weird. And then when we try to decrypt it, we can give it the private key. Process. This should take a little bit longer. It's been processed, and we can see that we have our decrypted image. So now we can move on to DES.
Okay, so my name is Andres. I was in charge of implementing the DES cipher algorithm. So DES is a symmetric block cipher, meaning that it's going to encrypt data in blocks of 64 bits. So we have this function here, encrypt file, which takes in the initial file. And then we have to make sure that the number of bits of the file is a multiple of 64. So for that, if it's not, I add some padding at the end of the file, adding extra zeros and preserving the last value of the remaining bits. So once we have that file with a multiple of 64 bits, then we can start encrypting every chunk. So if you scroll down a little bit to the encrypt function, here I just implemented the algorithm as described in class. So we go through an initial permutation, then we go through 16 Feistel rounds. For each round, we used a different subkey. So initially, we also have to generate 16 subkeys. Each is 48 bits. So we use one subkey per iteration. Then we swap the left and the right side of the ciphertext, and then at the end, we apply a final permutation. The decrypt function is just the reverse of the encrypt function. The only difference is that for the Feistel rounds, we first use the 16th subkey, and then we go all the way to the first. The rest of the functions are just helpers. You can see the F function, S box, and if you go to the permutation tables.java, that's where we have the permutation tables as arrays. So you can find the IP, IP1, and even if you scroll down a little bit, you can find the S box, which is the biggest one. So yeah, you can go ahead and do the demo for this.
And so we will go ahead and encrypt a video. The key will be generated for us. And we can see that the encrypted file has been put over here, train E. So if we try to decrypt that, it's been processed, and then we can watch our video over here and decrypt it. That's it for us.